Good afternoon, everybody, and welcome to today's webinar on reducing die design time, presented by Cimatron Group in cooperation with Metal Forming Magazine. My name is Brad Kuvan. I'm the editor of Metal Forming Magazine, and I'm pleased to serve as your moderator for today's session. Before I introduce our speaker, I'd like to first let you know that since today's session is being recorded for archiving, all participants are in listen-only mode. The speaker and the other listeners will not be able to hear any audio from your site during the program. Also, since we are recording this, a link to the recording will be available within the next few days on the websites of Cimatron and Metal Forming Magazine. During the session, you do have the ability to communicate with us by submitting questions using the question box in the right-hand control panel. Simply type your question to an organizer as selected from the drop-down menu box. Our speaker will address your questions at the end of today's presentation as time allows. Cimatron is a world leader in CAD/CAM solutions for mold, tool, and die makers with 25+ years of expertise, operations in 35 countries, and more than 40,000 installations. As I said, my name is Brad Kuvan. I'm the editor of Metal Forming Magazine, and I'm pleased to be your moderator today. For the next 45 minutes or so, you'll be listening to our feature presenter, who's from Cimatron, Casey Field. Casey is an applications engineer with Cimatron. Prior to joining Cimatron, Casey spent 11 years as an engineer in the tooling industry, where he was responsible for job quoting, tool and fixture design, CNC programming, project engineering, and customer relations. During his 4 years with Cimatron, Casey has assisted hundreds of tool makers to improve design and manufacturing processes. So as I said, for the next 45 minutes or so, Casey will discuss procedures that you can use to quicken progressive die design processes. Use one integrated solution to go from accurate quoting all the way through to strip design and final production. So without further ado, I'll give you Casey Field.
Hi guys, thanks for joining today's webinar. Like Brad said, we'll please submit any questions you have as they come up. Just type them in there, and we'll take a look for at the end here. So we'll jump right into it, and we'll start off. So right now we're working with Cimatron version 9. Version 10 comes out shortly. There are a lot of great new features in version 10 that maybe we'll discuss at the end of today's webinar, but today we will be looking at through the version 9 process. So we're looking at cutting die designs by 25 to 30%. And of course, there's no one single button that's just going to save us all that time, but it's definitely accumulated over the whole process of the design. So what we're going to do is we're going to walk through from the beginning, from forming the strip layout right to our tool design, and we'll go step by step through the whole process. And we'll also hit on the coding aspect, and we'll show where all this time can be saved at. So I'm going to start off what we call our progressive die setup wizard. And this is just getting me going in the right format. And I can open up a Cimatron file, or I can always import a file from basically almost any format that's available out there today. You see, I just steps at Pro-E, Unigraphics, even 2D work as well. So today we'll look at grabbing a SAT file, and we'll convert it as we bring it into our design here. I'll also start off a new folder, and I have the option to work in metric or inches. So by hitting the big check mark there, it's going to open me up into an assembly format and bring my part onto my screen. So first thing I'm going to do is just going to hide my datums and take a little closer look at my part. So this is a full solid 3D model. Now if you're getting data that's not fully solidified, or maybe it's just a sheet body or it's just a skin, that's fine too. Cimatron can handle all those formats. If you're just getting 2D drawings or 2D prints, we can also take in that data as well, and we can fully create our 3D part off that geometry as well. So like I said, we're just going to walk through the whole process here. And if if we look on the right side of our screen here, the first thing we notice that there's all these little icons lined up for us here. And this is what we call our wizard. This kind of walks us through the process, kind of guides us down. I'll be working mostly from top to bottom here, giving you an idea of what kind of structure I'm going to follow. Now, Cimatron is a software that's geared towards mold makers and die makers. So everything we see here is not just you know, a few options that was added on into some generic CAD software. Everything we do is made for the die industry and the mold industry. So all these features and functions are all not just added in there; they're totally made and for the die industry. So I'm going to start off just by setting my part into the proper orientation that I want to use. So I'm just going to quickly create a UCS here. So I'm just going to locate it off of this feature right here. And I'm going to tell Cimatron now that that is where I want to guide my part through the process. So again, by using the button on the right side, simply pick my UCS, and now I can see I'm in the orientation I want to work with. So anything I do here, I don't want to mess up my original part. So what I'm going to start off by doing is what we call forming shapes. And we'll kind of walk down the line step by step by step, and it'll be broken down to a very nice process, easy to follow for the user and easy to follow for your customer in the end as well too. So right off the bat, I'll just keep my original part here, and I'll start off by adding in a forming shape. Basically copying it over, and we'll just give it a new name. And we'll call this die skin, which is going to be the first part that I'm going to do here. And we'll separate them out just 10 inches. Spacing doesn't matter here. This is just for a visual representation for us to work with. Okay, so we see I've got basically just a copy of the first part. So now I can do whatever I want to this part. I don't have to worry about modifying or ruining my original. I can always come back to it. So again, on the right side here, now one thing we'll notice is the first button here is setup. So our setup can tell us a few things. We can use a die set, a pre-made die set, which we'll see later on in the presentation, which can tie into you know, everything we see here. We can define our shut height, stroke, lift, punch locations, plate thicknesses, and this is all stuff that's fully customizable by the user. So every customer, every user has different different ways of designing different components they like to use. So this is one way where you can customize it yourself as far as which plates are going to be in there, what sizes are going to be in there, and also if you want to have different die sets as well. Again, we'll come back to it near the end here. So a couple of things that we're setting up in here is our material thickness. And I'm intentionally going to put this in at a wrong value, and we'll see why in a bit. And then we're defining our material. So our material is going to be defined so that we get the proper K factor for all our bending and all our unfolding and blanking and everything else here. So if the material you're using is not on this list, you can always add it yourself. Cimatron gives you the ability to add in your own customized materials or even copying them and modifying them as you go here. And you can see every material has its own built-in K factors right here. Next is our progressions, and then we can see minimum distances, margins, and everything else. These values you can also set and save as defaults, or we can leave them and we'll come back to them, and we'll see how we're going to set them manually anyways. And the last one is setting up our punch types. So we've got 4 default types of punches we want through our die plates and die shoe. And you can see when we create our punches later on too, how we're going to set up all our clearances. So again, I'll just leave it at 124 for now. So like I said, this is what we call our die skin. So we're kind of working down the process. I'm going to create a die skin off this 3D solid part now. So I just simply pick which side I'm going to work with, and as long as my geometry is fairly smooth, it will go ahead and grab the one side for me. And right off the bat, I noticed that Cimatron does a quick analysis for me. It tells me that I've set up, in my setup, I got 124 thousandths of an inch. And when it does my die skin, it automatically checks the wall thickness for me, just in case I forgot, or in case I would have put in maybe the wrong number. So it tells me that the thickness of the part is actually 80 thou. It doesn't match what I have in the setup. So I can simply just say yes, go ahead, and that will update the setup for me automatically. So now I don't have to worry about having the wrong thickness, and then which gives me the wrong K factor, which is going to be some incorrect bending and unfolding and unblanking. So here's my nice clean die skin, and I'm just going to quickly change it to another color. So we'll go with blue here. And again, so Cimatrons, we're very flexible. You don't have to go through and do your whole die design. If you just want to maybe quickly just get a part in and go right to a blank, we can always, right at this point right now, click on the blank function. And we can go right into a blank. Now, obviously, this won't be as accurate as going through the whole steps and unbending and doing all your forming as it would if you were to do it in the proper progression. But if you just want to get a real quick size, maybe get a real quick layout, just to get a quote going, this is plenty accurate enough. And we'll see at the end here, we can also compare this blank to our other blank that we're going to progressively work on. So again, I'll copy this shape over again. So I'm just going to copy, and we'll just call this Form 1. And I don't want to skip it, so I'll skip it past the blank here. And again, apply. So Cimatron is what we call a hybrid modeler. So we can work with solids. As you can see, you have a nice solids tab right here. All your full capabilities of any kind of solid modeling. We can also work with faces. But what allows us is our flexibility is that we can do a lot of face operations on solid models, and we can also do a lot of solid operations on faces. So we're not limited to just working with one or the other. So if a model doesn't come in correctly, we're very efficiently to fix it, and if we need to design a model from scratch, we can also efficiently do that as well too. So we'll start off by removing this strengthening bump here. So again, even though this is a sheet body, I can use a nice solid operation and just tell it to simply remove that feature, and I have no problem cleaning up the rest of it. And now I'm going to do some simple color coding, and this will just help me guide as I walk down the line here. So this is the first area that I'm going to work with. So I'm going to color code it yellow, and then we're going to add this shape again. And we'll call this number 2. So I slide it down. So one of the first features for unbending and unfolding on more simplified geometry, we'll use the unbend option here. So again, I find the option on the right side. I can also find the option up here, but again, I use the wizard. It really guides me right through it. So I'm going to say unbend, and I want to keep everything down to this planar face here, and we want to unbend by this radius. Since I'm smart enough to realize what we're looking for, it actually grabs the rest of the geometry for me. Excuse me. So of course I can bend it right to flat. We can even preview it. Or if I want, I can type in any angle I want, and I could do this in a couple hits if I prefer. But for this demo, we'll just go right to flat. So we'll apply that one. And then we'll do, again, coming to this flat, around this radius, and again, right to flat. So we flatten out the first flange of our part here. So I'm just going to go back and color code again. This area has been worked on. And then I'm going to look at what area I'm going to work on next. So we'll come down to this other similar flanged edge. Again, color coding it. Color coding just helps me later on when I'm working in my strip in my design to follow what progression I'm working on here. Again, we'll add our next Form 3. And even though this is a very similar unbend condition, we notice that the geometry is a little more complex. We don't have just smooth cylindrical bodies or planar faces. So we use a little different method here. So what we're going to use now is what we call local blank. So clicking the local blank option. Again, I'm going to blank it down to this flat right here. And then I can define which areas I want to select to blank. Now, local blank has a couple nice features in it. Now, first off is I can adjust what we call our region, our offset of influence. So it's not just that when we form this portion of it, it's just going to hold that tightly there. We know that there might be an area that's going to be affected. So we can see this bright yellow line here. I can tell it maybe that, give a good guess how far it's going to be affected back. Maybe we'll go with 60 thou. So what it's going to do now is when we come down to our blank, it's going to also take this extra 60 thou region into effect. And again, we'll apply. And now we notice that the part is not just going straight out. It's actually skewed because of geometry. That's local blank. So the next area is going to be a little more complex. We're going to look at the upper flange here. So again, I'll just simply define that's the area I'm working on next. And then we'll add our next shape here, Form 4. So this is definitely a much more complex area. So we'll start off and we'll use a feature we call blank on binder. So our blank on binder, we can define any binder body we want. We can develop it. It can be smooth. It can have all kinds of form and shape to it. But we've defined what we want to form it onto, and then we just take the shape and we form it down to it. So I'll simply just split up this area from the rest of it. And we'll just hide it out temporarily while we work on our binder body. So now, like I said, Cimatron has lots of tools for modeling solids and faces, and even though it's the sheet body, we'll do some face operations here. So I'll start off just by creating an extension surface, and we'll go out 1.5 inches or so. And likewise up here as well too. And this is one where I can also extend using a composite curve. So instead of having to do it 3 times over, I can do it quickly in 1 step. So surface manipulation is very important in a good CAD software, having a lot of control. So I see here, even though it extends off the surface, nice and flat, I kind of want to keep this edge kind of running tangent, so I can just simply pick that surface and give it some manual control as well too. So we'll add this edge as reference. And then just tell it simply that I would like this line and this line to stay tangent to each other. So the thing I want to do, I just want to fill in the blanks here, and we'll just simply make a quick, smooth line. Help me guide it, keep my surfaces nice and smooth. We don't want to have to manufacture anything kind of sharp corners or anything that's going to be having to get detailed out here. So quickly blend from side to side, and just make sure that we're going to follow this edge and as well this edge. So I've got a nice smooth surface in there. And the last little edge here, I'll just simply drive out this edge. So again, there's many ways we can do this. This is just one using faces. And the last thing we do is just stitch it together. So we can see we've got 4 individual surfaces, and now we've got one nice stitch body. And let's bring back our flange here. And now we want to tell it to fold this down onto what we call our binder. So we'll use the option blank on binder. There's my binder. There is my flange. And again, I have the option here to trim my binder or to leave it the way it was, but it gives me a chance to look at some of our analysis tools here. So analysis tools built right into most of the features you see. It was already in the local blank observation, I believe, but we didn't look at it. So we have a thickness strain analysis and also a safety zone analysis. So we'll take a second to calculate. So this is the thickness strain, and this is just giving us color coding. And you see the chart on the right side. In this operation, what kind of thinning or thickening of the plastic are we going to get? So obviously, we're going to see any areas of poor conditions. And then we also have our safety zone analysis as well too. This will show us areas that could possibly fail, that could wrinkle, and also strong wrinkle tendencies, and areas that are typically regarded as safe. So you can see this can help you define if you want to do this in maybe 1 or 2 forms or 2 hits. Go ahead and apply. You can see now it's taking that whole edge and folded it right down onto our part here. Now I'll simply just stitch them together, keep it a nice, come on nice and clean. And so the next area we're going to look at now is going to be the center of the part here and the bump. So we'll simply, again, grab this area. And that's our next area that we're working on. So again, defined as yellow. So simply, again, and this we can use a similar option, but one that we call auto blank on binder. So the last one we used, we made our own binder body. It can be any kind of geometry at all. This one we're going to use auto blank on binder, which allows us to pick any kind of cylindrical or planar or conical faces. So this bottom face right here, you can see, obviously any put my mouse over it, it won't let me pick anything but cylindrical, conical, or planar, so I don't have to guess whether it is or not. So I picked the face there, and then I can simply pick even just one face on the area. It is smart enough to calculate and pick the rest of it for me. And again, we're going to go And we also have our analysis tools again as well. We'll hit OK. And this will blank us right down to there. Now our part is done here. So the last area we're going to work on is this guy right here. Again, forming shape, add. And if you want to understand why I'm color coding and how it is the process, if we take a step back here, we can see the progression down the line here. So I can even start off again with my original part to a skin, right to a blank. Maybe that might be good enough for what you're doing. If not, we keep going, and I can see I'm breaking it down into each section. The yellow depicting of what area I'm working on in that progression. And again, we don't have to be specific here. It doesn't have to be 100% right, because when we come into our strip, we can always mix and match which order we're going in here. So it's not like we're tied to this. Very flexible. So we're going to come in now, and we're going to look at our last one. And again, I'll just use our blank on binder function, and I'm just going to take my surface here, and I'm just going to make it much larger to use as a binder body. This is my surface. So it's generated off of this one here, but I can stretch and pull it to any size I want. So again, I'll just say blank on binder. Here's my binder body, and this is the area that I'm working with. So again, it'll take that whole shape and form it down until I've got a nice, clean, almost flat part. So again, I'll just keep everything together. Go back to our nice color here. And the last thing we're going to do now is create our final blank. So the blank option, click my part, and again, apply. Here is my final blank. So this is the one that I'm going to use to actually create my strip layout with now. Save my file. And so Cimatron has this broken down into basically 3 steps: forming, strip, and tool design. So that was basically getting through the whole section of our forming. So now we're going to get into our strip. So I'm just going to go to the bottom of my menu here, and you can see there's icons kind of hidden, but I can say switch to strip, switch to tool. So now I'm going to switch over to strip design. So we're still in the same file. We're not changing anything. All we're doing now is basically changing our menu structure, allowing us to use all the tools that we want for our strip layout now. So again, I'm working top down. The setup's already been taken care of, so I'm going to jump right into my nesting. And we have the option here of using 1 part or 2 parts. Now, at the very beginning, I didn't mention this, but you can also bring in different data into this file. You don't have to be working with the same part. You can bring in multiple parts to start off with. So here I'm going to use 1 part, and I'm just going to say this is the blank I'm using. And we'll see right off the bat. And at this point now, I can temporarily hide out all my forming shapes. So showing me 4 right now. This is just getting us going, just to get us a rough idea. And we can see a couple things here. It'll automatically adjust and tell us what the blank area, the scrap area, and the progression area is. So I can try to minimize how much scrap if I can rotate or shift the parts around. So I can see here I can shift, and as we go, we are modifying rotation of the part. And you can see it's also updating the scrap area and blank area and progression area as we go too. And I can also define a few variables about how minimum distance between parts, and obviously the angles as well too. So keep this simple. Let's go to 90 degrees. And if we wanted to as well, we can use multiple parts in here, and they can both have multiple angles to fit them in as best as possible. So we'll stick with one here. So once I have my nesting done, and again, everything is parametric, so once I've created my nesting, if I decide I want to change later on, maybe to carry the part easier, I can simply go back and edit my nesting at any time. Edit nesting right here. The next thing I'm going to do is create my strip dimension. So basically tell it how many progressions I'm going to have and the overall size of my strip here. So we see it tells us we're looking at 9.3 is basically what we need, so we'll round it up to 10 inches. And I'm just going to guess that we're going to need about maybe 10 progressions here. So we can see here's our actual strip now, starting off with our length. And now I can start defining a bunch of things in here. Areas that I'm going to be punching, areas that I'm going to use for carriers. And I can just draw it in freehand. I can draw it in very detailed. I could even bring in a catalog of sketches. So we'll start off just by drawing a sketch on here. And we'll pop a couple holes in that we'll use to guide the part through. Again, I'm just doing this very quick, so it won't be as accurate if I was taking a little more time here. So, and again, I'm just going to draw in. And some of my lines you won't see, I'm not worrying about them to be matching up with other edges, and we'll see when we actually draw in our punches, it's not going to be overly critical because we have a nice feature just to help us out with all our shapes. And let's go to a 1/2 inch here. And of course, even though I'm roughening it real fast here, I can always add a reference to edges, lines, circles, everything else. And of course, make it as accurate as I need. So let's keep this at, let's say, 1/4 inch. So simply dimension those values in there. And also we'll so good enough, and somehow I'm going to divide this up here as well. And I want to come right off of this edge, so I'll simply tell Cimatron that we want to add some reference to it. And good enough for now. So we can see here, I just kind of draw it in real fast. And I'm going to tell it now to make what we call define our punch areas. So first off, we'll look at a real simple one, and maybe one of this, a slot here. Just simply by picking inside the slot area, it's going to grab that contour, and then I can define it as a punch. So defining as a punch, tell Cimatron a few things later on down the process as well too. And we're just going to tell that we're going to punch it in this station right here. By applying it, we'll see our punch areas in green, and you see the rest of the way down, it's been trimmed out now. So that's a nice simple one. Let's look at a more complex one. So we'll say again, punch, trim, curve. And now I can just pick to find the area where I want my curve to be. And we'll hit, we'll add a radiuses in here. So I don't want any sharp corners, so I'm going to say give me a 30 thou radius everywhere. But some of the areas here, I can probably put a larger radius in. So we'll go to 1/4 inch in areas that we know are not going to matter. And again, define that area as a punch, which will strike in this section right here. So again, bright green, that's the punch area. You can see the rest of it's all being trimmed out as we go. And we'll do one more real quick. And this one will actually use our nice feature, what we call for cookie. So what cookie is going to allow us to do, we're going to create an overlap or extension on this end here, and we'll extend it out so that we're not going to be size for size with my last cut. And same thing, I'm going to add a small radius everywhere with a large radius where it's allowed. So here's my next punch. And we'll strike that one right where it's at. So now we can see kind of the progression down the line here, starting off with solid strip and then punching out the stock, and now we're getting into our forming shapes now. So we'll just quickly trim out the rest of our stock here right to the end. And then we'll look at how we're going to bring our forming shapes right into our strip. So again, on the right-hand side, I'm just going to add my forming shapes, and there they go. They pop up for me. So now I'm kind of working backwards. So I'm working from the part down to flat steel, and now I'm working from flat steel back to my final part. So I'll just start by grabbing my first part and just telling it where it's going to go. So I'm working my way back down. And again, if we want to add in an idle station, this is where we can just simply pick the part and add it in again as an idle station or a restrike, or we can keep going in and adding it as we go. I can see I've got my file here, and it looks like I've got maybe one extra that I don't need. I either use it as a cutoff, or I can define it. I can always go back and edit my strip and say I don't need 10. I'm only going to work with 9. Okay, so we're running a little slow on time here, so I'm going to jump ahead here. Close this off, and we'll look at another one that I did. So this is basically the same part, a little more detailed in defining our punches. And see, I've also added some PMI, what we call product manufacturing information, which is all these dimensions here, which are just basically dimensions in our 3D environment. It may save us some time conveying information from here to manufacturing, which definitely cuts down on your overall die design. Anytime there's information not getting a good information flow, there's always that time with the shop coming up to talk to design and so on. So this is a nice way to get all the information down there, and to avoid making as many detailed prints that might happen in the past here. So a few things. So I've got all my parts defined up, and you can see this is my nice strip. Now right away, once I get this part right here, I want to show you guys a nice option we have for die quoting. So we'll open up what we call our die quote generator. So everything I've been putting in this file, like as I've been going, picking how many progressions, picking all my parts and everything else, what I can do now is just simply tell my die quote just to match up with that file, and pull all the information that I put in there. We'll grab this part. We'll simply tell it to load the data in. So we have a lot of stuff here. The material type, the number of parts, the part thickness, the blank area, the number of progressions, everything else. So what we can do now is we can update our general setup data. which take all the information from our file and put it right into this area right here. And then the same thing at the bottom. We can see all of our punch areas and all of our form areas that are defined here. So we'll just update them all and give a and we'll bring this information in as well. So now we've copied all our information right into our die quote options here. And we can see, so this is fully customizable as well. So you can see everything that's in here I can have from a customer list. So I can give it a quote name, automatically generate one. I can pick from a user-defined customer list. I can give it a certain job number. I can say whether this is approved, submitted, rejected, what kind of category. Maybe if you have certain customers you consider VIP or give them maybe a certain discount to, you can always depict it here. How many parts, percentage markup, and any kind of quote info or any kind of comments you want to add as we go here. All the information we see here all comes right from our file. Number of stations, the material, the work area, the width, length, scrap area. So likewise, if we go back and change it, maybe add another progression, another station, maybe change our blank, we can simply come back into our quote, update it, and everything will stay nice and solid here. And at the bottom, we can define our, again, everything comes over automatically. At the bottom here, we have all of our punches, whatever we had labeled them, and then any areas that we defined for forms as well too. So we can, from our list, again, from a fully customizable list, we can tell it which one we're going to do. Say this is going to be a wire punch. And as we're filling these out, there's a bunch of values already assigned to them. So if we scroll over, we can see there's going to be unit cost, which can be fixed, which can be based on the area, which can be defined by a contour, or it can just be a fixed cost. It can be defined by machine unit cost. This is, again, everything we put up right in our own user library here. So again, if I want to add something new, simply add a new one, give it a name. We'll call this machine form, working in inches. And again, it can be just a fixed material cost, $500, and maybe even a machine cost, or it can be by contour, so depict depending on the size. So and now we've added that to our library. So if we come down here, and again, this is not a library, just this is an overall database that's updating constantly. So if we add it for this job, it's going to be available for any of our next jobs as well too. So there's a form shape, and now we can always define it. This maybe be a machine form, but that it fills in those values as well too. We can also take screenshots directly from our file and add pictures into here. And as we're updating our everything here, so we can also select our press. Again, this is from a user library. Values can all come in automatically. And once we're all set here, we can work on a couple things. We can work on our part price, and we can work on our overall die price. Type in taxes, special discounts if they're available, and so on. And once we're done, we simply click the report option here. Grab a template, and we'll open up. So this will automatically create an H report that we can send off to the customer or keep internally as well too. And again, everything is linked right to our design. So as our design changes, so does the quote. So jump back into our part here. This one we don't need. So now we want to look at taking this strip design right into our tool design. So we're going to jump back in again, looking from our right side. We're going to say switch over to tool design, which I'm already in right now. So I just simply say new die set. So die set, the one we use here is actually part of Cimatron's library. Cimatron gives us a few examples to work with. But again, this is fully customizable. Every user has different standards they use, different components they use. So we allow you, the user, to define whatever you want. Of course, you can always use one from Cimatron's library, or you can even copy from Cimatron's library and modify to your own standards. So this die set can be consisted of, as little as 5, 10 components. It could have hundreds of components in it, as far as or as accurate as you want to go. So I'm just going to place this in, and we're going to place right by the center of my strip. And we can see it's definitely not the right size, but it gets us going here. So again, we're still working in an assembly environment. This is broken down into die side, punch side, stripper side. And now we want to just look at modifying this and getting us into quickly sizing it up. So if we had to build this every time from scratch, we would be looking at hours every time. What's nice now, and to show it, I'll just turn off our punch and stripper side here. So we notice that maybe right now we're not the right sizes, but we can simply adjust it by a couple clicks. We want this to be 10-inch wide for our strip. Simply hit update, and everything's going to shift accordingly. So bushings, screws, pins, any kind of guides, they're all going to adjust. Everything is tied together, and likewise for our length as well too. So our default length is in here, just at 60 inches. So we want to go to, we're at 92 here. So we'll just simply type in the 92, update, and again, all our values are going to update for us automatically. So very nice, very quick to really get going on a quick design and using the die setup here. Let me again jump ahead. The last section. This is a partially done design. You can see the strip is all fully created off our forming shapes. And now we have our die set, and we've started to add in a few components in here as well too. You see we made a few punches already. I've called them profile 1, profile 2, and slot punch, and also a round pin one. So we'll look at adding in another one as well too. So we'll simply come over to here, and again on the right side we're just going to say we want to add a new punch. Trimming punch, and I want to put it in my punch side, and we'll call this profile 3. By grabbing just a simple face, I can define where my punch is. So this is the same face that I defined earlier, right in my strip layout, and you can see right away it grabs that profile and defines my punch for me. I can just give it a delta value, or I can also give it a reference value, and I can pick a surface or a plane or any kind of geometry to define where I want my punch to go. And the nice thing here is that now for all of our holes, so instead of having to manually do our cuts and drafts and everything else, relief cuts, this is all taken care of within one step. So I can just define, we have our stripper plate and our die shoe, and so how we're going to cut it is which type is listed here. So how do you want your clearance to go? So we'll go with type 1, and we'll simply hit. Okay, so this will all in one step create our punch and also all our relief and all our clearances that go with it. Okay. I like to color code my working parts here. So if we hide out the punch, or actually if we just look at it through a dynamic section, we'll see that our punch is defined, and it automatically puts whatever clearance we defined it as. So our clearance size here, our drafted relief, and then our clearance through our die shoe. And again, if we're not working with the same set of plates, maybe we're not working with the subplate, but we're working with inserts, that's fine too. So whatever we select to cut, whatever we tell it to cut, we can also adjust the clearances as well automatically. Next thing we want to look at is adding in forming shapes. So Cimatron, because we are so strong in modeling capabilities, we have no problem creating any kind of complex forms or shapes here. Here's one we've already added in here. A couple of screws as well too. So everything we're adding to our job as we go, we notice we come from Cimatron's extensive library catalog of tools. So if we come and just look at quickly our list of catalogs, we can see these are all just default catalogs that come with Cimatron. You can also customize and make your own list of catalogs. So there's going to be thousands of catalogs already created. So here we see in the Mizumi section punches and pilots and buttons and everything else here. I mean, more than I can even have time to scroll through here. So, but again, anything that's not there that's required, you can always import it, or you can always create a catalog for yourself as well. All the catalogs come with all the what we call cutting objects or the holes, so you never have to put in a screw and then have to modify it and put in the hole for the screw and so on. You just add the screw, it puts all the holes in for us automatically. We only got a few more minutes here, so I will quickly add in another forming shape real quick. Under forming shape 4 here, we'll activate, let's hide everything else again. So let's look at adding in our forming shape, this part right here. So I'm just going to import my geometry over right to my shape, just the areas that I want to work with. Removing any curves that are not required there. And then a real nice feature that we have is I'll just be able to sketch a boundary on here, really at any easy level plane. And what I can do is for my surface extensions. So we'll just quickly, any boundary size, and I'll use a nice option we call extend planar and cones. So by picking my surfaces and picking my contour, Cimatron will automatically find anything that's going to be planar conical and drive it out to my contour. So I don't have to worry about spending, you know, an hour or so trying to make all these surfaces and make sure they're tangent and smooth. So I can just keep really quick, and then I can define my surface as well. So I know I want to spend a little more time on here, but I also want to hopefully answer some questions as well too. I know.
Casey, did you want to go ahead and take some questions while you're working?
Yeah.
Okay.
Let's see if any questions that have come up. Go ahead, Brad. If
yeah, we got several.
Okay.
And please, everybody, if we don't get to your questions, we will address them via email. So we'll do the best we can here. The first question is everything that you showed today, Casey, standard with Cimatron, or some of that optional features?
Yeah. The bulk of what I've shown you is standard. Yeah, there are a few options that, are modular. So it's basically, we're not trying to have you pay for anything you don't need. So some of the high-end features there can be added on for an additional fee.
Okay. The springback function, which is in version 10, when will that version be available?
Yeah, I had a little springback to show you, but I think we're out of time here. Version 10 comes out very shortly, probably in the next few weeks. And look forward. There's a great springback option in there. I'm sure you'll see it on a upcoming webinar, and we're definitely going to show it in any kind of user group meetings coming up as well too.
Okay. Question is, can I modify a blank that the software has created before developing my strip layout?
Yeah, sure. Sure. Obviously, Cimatron is going to take your part and make what it considers to be the blank, but we know that in design, I mean, there's always areas that we have tolerance and we want to stay maybe safe on. So you can always modify your blank before creating your strip. You can just simply add in offsets or different sizes as you see fit.
Okay. Can you talk a little bit about the learning curve with the software? How long does it take, kind of the steps along the way?
Oh, okay. Typically, for die design, we break it down into 2 weeks of training. Usually one is more geared towards the CAD, the modeling, solids, and surfaces. And the second is more geared towards the actual die design itself. And then once a user's been trained, it's typically about another month before they're really efficient at using it and seeing the 25 to 30% increase.
Okay. What about processor requirements? What are the minimum processor requirements?
The processing requirements are not overly high. We do always keep a document live that's going, but typically a lot of it's depending on what kind of tooling you're doing. The larger die is obviously going to require a little more RAM, but processing is anything your standard computers are using today. Even in the last couple of years, we haven't seen any problems with computing power. So
good. Okay. The question is, as the die set increases or decreases, does the software go ahead and change the pin and bushing diameters?
Yeah. Again, it's totally customizable to wherever you want. So you can have those. I've seen customers who have 3 different die sets: small, medium, large, where those pin sizes are set, and other people who just keep it as one die set and they have it tied to a formula. So if the plates get beyond a certain size, it will automatically jump up to the next bushing and leader pin size.
Mm-hmm. Okay. We have several attendees in Mexico. Do you have support and training in Mexico for the product?
Yeah, we support Cimatron all throughout North America. So that's USA, Canada, and of course Mexico. We've done many training sessions recently in the Mexico area. And again, training is up to the user and whatever's going to be best for them. We can do training on site, or we can do it in our training facilities.
All right, we're at that hour time limit. Does anybody else have any last-minute questions before we sign off? All right, it looks like we're good to go. Did you want to talk about that last slide there? Or?
Yeah, we should have a slide here. This is just a customer of ours that's been running Cimatron for quite a while, and they switched over from a 2D design software, and they actually use Cimatron now for 3D design, and also through the shop floor for all their machining and manufacturing, and obviously he's been very happy with it. And he says overall we are about 25 to 30% more efficient than we used to be. Complex strips that used to take 3 to 4 days now take 3 to 4 hours of design. Labor on manual machining processes have been down to a minimum. So, and again, you can read about them too at our website as well.
Good.
Any
okay,
questions?
very good. Yep,
Okay.
your contact information is there. We have a couple questions about how to get quotes and demos, and I'm sure that those types of questions can be addressed directly to KC, kfield@cimatrontech.com. Thank you once again, everybody, for attending today's program. We hope you found it useful. Also, please remember that the program is recorded and archived and will soon be available at the websites of Cimatron as well as Metal Forming Magazine. So you'll be able to go back and review what you learned today and share it with others within your organization. So you may go ahead and close your browsers now, and I wish everybody a great afternoon. Bye-bye.